it in this lesson. Yeah, because in a 2-hour lesson, I need to finish like 2 chapters. It's actually very rushed already. So I just go through like the bulk that majority needs lor. Yeah. Okay, so let me do a brief introduction of myself as well as Overmark. Yep, so for the lesson today, it will be conducted by our team, Overmark tutors. So just to let you know that for Overmark tutors, we are all specialist tutors. Like for me, I teach mainly IP classes. And then there are other teachers that teach like the express classes and all. And then we are all at least university graduates. With at least decent years of teaching experience. So I'm actually one of the oldest here at Overmark lah. So so I'm the 13 years of teaching experience one. Later I'll share more with you of my teaching experience. Then at Overmark, we teach O levels, IP, and also JC A levels. So then for Overmark, we are located at these 3 main branches. So for the physical students, you are here now with me at the Bukit Timah branch. Then we also have so we have West Center, which is Bukit Timah. We have East Center, which is at Marine Parade, the Parkway Center. And we also have more central a little bit. That's Kovan at Upper Serangoon Road. And besides our 3 centers, we also do have like classroom space. These are not exactly Overmark like centers, but more of like we rent their classroom to teach. So there are less classes there, but we do teach like at these spaces. Then so as for I myself, so this is my name. I'm Miss Felicia and so far I've been teaching mainly O levels and IP classes. I teach all 3 sciences. That's why I teach from lower sec all the way until like upper sec. And these are my track record so far. So previously, I actually graduated from NTU, major in sciences. That's why I'm teaching science now. And that so far, my teaching profile is that I've been teaching IP and O-level classes, mainly IP, both upper sec and lower sec. So before I joined Overmark, previously I was actually at the Learning Lab for 7 years back then. And that even before Learning Lab, I was also at another tuition center called Wisland, and I also did like quite a lot of like MOE relief teaching, previously too. So these are photos of my students. So my classes, like I do conduct like experiments, so that like to let you see for yourself how science classes run. So then for Overmark, we always like have like welfare sessions. So like just now for my classes, like we just like ordered koi. So it's like my koi, I haven't even finished it. So for the physical students later, like if I were to get to give you a toilet break, you can go to the pantry area. There's actually a free snack bar. You can take anything you want. You can bring it in the classroom to eat. So Overmark here, we are a very welfare kind of center where we will like once and then we order like pizza, koi, acai affairs from downstairs. Then we also have free snacks bar. Then if you want to like reach the center earlier to study, or even on your non-tuition days, you want to come and study, I think some of y'all can see, right, there are actually like common study areas, where you can study, which has free Wi-Fi, charging ports and all. And then got even like some simple games like card game and stuff you can play with your friends before lesson starts. Okay, so for the lesson for today, we will be doing the notes first. As you can see, right, the materials that you have downloaded. We will first do the notes where I will recap the key concepts that you need. And that we will address misconception. So later I'll highlight to you the mistake that your friend will be making. Then you don't make this mistake, okay? Because it's highlighted to you. And that we will actually, I will guide you through some questions, the difficult ones, so that hopefully with the skills learned today, you will be able to apply it to like the questions inside. So for today, there will also be some questions that I'll be letting you to take home to practice it. Then at the end of the session today, I will be giving you the answer key. So for those online students, you must stay all the way to the end so that you can get the answer key for the worksheet for today. Okay, so without further ado, let me begin the lesson now. Okay, so for those of you who just came online, can you scan this QR code now to download the lesson material? Okay? So make sure that you have a copy that you can write on, be it soft copy or hard copy, it doesn't matter. As long as you can write will do. Because we will have notes to highlight and we will have worksheet questions to practice on it. Yeah, sure, go ahead. Okay, so I take it that all of you done downloading the material, so I shall change the screen and remove the QR code. All good? Okay, since no violent objection, okay, I shall move on. Okay, so yep, let's start off with CAN bonding first, because this is the focus for the WA2. You need to know that in CAN bonding, mainly it would be three main types of bonding: ionic, covalent, and metallic. So usually when you see any worksheet question, first thing is you must always be able to identify what type of bonding. Because if you identify the wrong type of bonding, then your whole question, your answer, everything will be wrong, right? So to decide, you always check the substances. Are they metals or non-metals? But it's not so straightforward. Later, I can show you some question that is like, it can indirectly be another kind of bonding. Yep. Okay, so I go through the basics first. So for ionic bonding, it's usually one of them is non-metal, the other one is metal. Yep. Then when they are bonded together, we call it as ionic bonding. And need to know the structure. It's called giant ionic lattice structure. One of the common thing that I realized for students that they didn't realize it is that they didn't realize that ionic bonding is actually giant. And what do we mean by giant? Giant always consists of like, I would say like hundreds or thousands of atoms. So it's hundreds or thousands. Okay, by the way, for my lesson, right, is that whatever that I highlight or I write on the screen, you follow me and copy it down. So that means by right, my screen and your worksheet should be the same. Okay, so you follow and copy everything in. So that means if I give you maybe like what 40, 60, 80, you might think that what 80 atoms like a lot, right? If you need to go and count 80 atoms, but actually 80 is still considered very little in chemistry. Yeah, so for chemistry, for high, the benchmark is it must be in hundreds or thousands. Yep, so in ionic bonding, take note that it's not just one Na and one Cl, then there's one one ionic bond, that's it. Ionic bonding is not just one line. Yeah, it's actually, can you see, it's actually a giant structure where many Na and Cl, they are bonded together. Okay, so that means there's actually a lot of attractions happening. They're not just one. Okay, then next it would be covalent. Covalent would be both of them, non-metal and non-metal bonded together. Then it would be either one structure. So it will be either simple molecular structure or giant molecular structure. Then based on what I heard from my Nanyang class is that my Nanyang student told me that the school note says that your school write as simple, either simple molecular structure or simple covalent structure, just to let you know in case you're finding it confusing, is that usually covalent is a bonding, like covalent bonding, ionic bonding. So by right, it's not called simple covalent structure lah. In terms of structure, we call it as simple molecular structure instead. So molecular is a more correct term. Because covalent is bonding, molecular is structure. Cause structure means how you are going to arrange it. So you see, like in this case, you arrange it in the neat and regular arrangement. This is called lattice structure. Like you see over here, for metallic bonding, you see it's neat rows. So whenever it's neat, organized structure, that is called lattice. But for covalent bonding, they exist as molecules. Can you see like 4 circles together? So this is a molecule. Because if you recall your lower sec, like your sec 1, sec 2 concept on the elements, compounds, mixtures topic, so back then you actually learn the words like atom versus molecules. Yep, so need to know that for atom, it will refer to just one circle. That means atom is like singular. As compared to molecule, molecule will be like water, right? Water is like H2O. So H2O is 2H and 1O. That's 3 circles. So for molecules, it will be like okay, 1 circle versus molecule is 2 or more circles. So that means molecule is like plural. So for covalent bonding, we are trying to say that there are many circles connected together. So this is molecule. Yeah, so this is actually the structure, because that's how you arrange them. You arrange many circles together. Yeah, that's why we use the word molecular for structure. Or sometimes you will see, instead of writing simple molecular structure, you might see your school notes say that, oh, it exists as discrete molecules. So discrete molecules. Molecules is the same as molecular. The root word is still molecule. Yeah, so you can write either. Okay, then next for giant molecular structure, I would say that for your syllabus, it would be mainly these 3 lah. So if there is something else that you feel that, this question, is it testing on giant covalent? You think twice, because I would say majority is that usually they only test these 3. If they test you something else, high likely majority of it lands in simple molecular instead. Yeah, so actually giant is like more like strictly only these three. But of course, there might be exceptions. So you have to like read the question for the hints. So they might tell you like the boiling melting point, or they might give you like about like the other properties. That's when you can deduce. So later I'll be going through questions with you to deduce like what kind of bonding it is. Then for metallic bonding, it would be there is fixed cation and there is sea of delocalized electrons that can move around. Yeah. Okay, so then now let's zoom in into how to answer questions. So usually for my chemistry classes, my notes is always focused on how to answer open-ended question. Because usually for students, weakness is that you can't answer the open-ended question, right? Because somehow we'll miss out this keyword, miss out that keyword. Yeah, so this is actually the summary, and behind there is actually the answering technique. So answering technique means that it's the standard template answer. So as long as you know you put in your effort, you study hard, you remember this template answer, then you write in the explain answers, question that asks you to explain, you write it in, right? By right, you can get full marks already lah, because all the key points are included in already. Okay, so let me start off with the first table here first, which is the definition. So for definition, if you realize all of them are actually on electrostatic force of attraction. It's just that they attract different things. So for ionic bonding, as the name suggests, ionic bonding means got the word ions, right? That means the attraction is between the ions. Yep, so can you follow me and write it down? So need to know that ionic bonding substances will exist as ions. And hence the name, right? Like ionic bonding, yeah, the name got the word ions. That's why they exist as ions. Not molecules, not atoms. Next would be simple molecular structure. What is the attraction? The attraction would be not between ions. Because covalent don't have the word ions. So they don't exist as ion. And as mentioned just now, they exist as molecules. By the way, if you're wondering what's discrete, discrete means simple and separate. Yeah, so it's like individual, and then each time when you draw the molecule, it's not that many. It's like the circle is like maybe just a few circles only. Yep. So as the name suggests, molecular means they exist as molecules. For giant molecular structure, you have to look at your situation. Yep. So different substance, their structure is different. Then for metallic bonding, yep, it's also giant. So you realize that actually out of all these, right, actually everybody is giant except simple molecular structure. You see? So you see all of them are giant. So need to know. So giant means actually is very big. So whatever diagram they show you is actually just one small section. So can you all like take note and underline it? So everybody is a giant structure except simple molecular structure. So take note. And then yep, so for the covalent bonding, it would be the attraction not between ions, but it would be the attraction between the valence electrons and all your other electrons with the nucleus, because your nucleus is positive charge, your electrons is negative charge. Opposite charge then will attract. Just like ionic bonding, positive charge and negative charge then will attract. So likewise for metallic bonding also, cation is positive charge, electron is negative charge, then will attract. So need to know what are attracting for each of the bonding. Is different things that are attracting. Okay, then moving on to the second row. This one I already mentioned just now in front, so I'm not going to go through it further. So next part is the structure. So this one is important because usually for majority of the question, you go and revise through the worksheet that you done in school, plus the worksheet that I'm giving today, you realize that there's a lot of questions that keep asking you explain in terms of structure and bonding. So whenever they ask you in terms of structure, you need to be able to identify what type of structure it is. So this one, very important. Yep, so this one need to know. Okay, then the next part, it would be what are the attractions? So need to know that ionic bonding is electrostatic force of attraction and it's strong. Then then for your worksheet question, if you were to write the electrostatic force of attraction, make sure to identify in context of the question. That means like if the question is NaCl, then please specify that it is between the oppositely charged Na plus and Cl minus ion. So must specify. Because if you just copy and paste and write it in, right, teacher will feel that like you are not understanding the question. So it's like you're just regurgitating. Then they may not give you the full marks. Yeah, so must answer in context to show that yes, you really understand the question and you're applying in context of the question. No? Next, for simple molecular structure, take note that the focus is actually the weak intermolecular force of attraction. For the strong covalent bond, we seldom mention on it is because it's too strong. So it's so strong that you cannot break it. So usually for open-ended answer, we tend not to talk about the covalent bonds. Okay, so that means like if question is on water, carbon dioxide, there's no need to mention covalent bond. Just mention the weak intermolecular force of attraction would be good enough. And by the way, weak intermolecular force of attraction, this force of attraction, another name for it is called van der Waals. Yeah, both are the same. Okay, then next one, giant molecular structure. This time round, no more intermolecular for diamond and sand. You only have intermolecular forces of attraction for graphite. Yeah, so the graphite still got intermolecular. But for diamond and sand, don't have. So diamond and sand, the focus will be covalent ones. So this covalent plus intermolecular. They need to know that covalent is always strong. Intermolecular force of attraction is always weak. Yeah, so that means once you see covalent, confirm is strong. Okay? Intermolecular force of attraction, confirm is weak. Then lastly, for metallic bonding, it would be electrostatic force of attraction. Yeah, which is strong. Highlighted, right? Okay, so I shall move on. Okay, so moving on to the next part here. These are the physical properties need to know. So for since we mentioned that for ionic bonding is so strong, strong means you need a lot of energy to overcome. So you just follow. As long as weak means it will be small energy. Then over here, strong. So strong, it will be large energy. So whenever it's strong, strong equals large. Weak equals small energy. So the amount of energy also decides your boiling melting point. So large means high, small means low. Then same thing, in chemistry, if I tell you the number 500, is 500 high or low? It's considered low. So in chemistry, for their high, their threshold is actually quite high. So generally, we would say that for boiling melting point, above 800 degrees Celsius is high, below 800 degrees Celsius would be low. So actually 500 is still relatively low. Yep. Yep, so then need to know the boiling melting point, which is related to the energy. Next, electrical conductivity. Only for ionic bonding is a bit tricky because depending on the state, different electrical conductivity. The rest is okay lah. The rest is always just one answer. Ionic got different answer, so just be a little bit careful. Next, just to let you know that a polar solvent over here refers to water. Can you write it in? Polar refers to water. Then non-polar is organic solvent. So organic solvent would be things that is made out of mainly like carbon, hydrogen, oxygen, like maybe ethanol. So ethanol is like found in our hand sanitizer, and those are actually organic solvent. Or maybe like oil. Oil is also organic solvent. Next, the volatility, whether does it evaporate easily. Volatile means easy evaporate. Not volatile means doesn't evaporate easily. And this one, don't need to memorize by heart, because you can link to boiling melting point. Because if your boiling melting point is so low, like example, room temperature can boil out. Isn't it? Boil means become gas. Isn't that evaporation? Because evaporation also you become gas. Yep. Yep, so that's why you can link to the boiling melting point to remember. Then the next part is whether the bond strong or weak. This one is covered above, so I shall move on. Next part, this is the part that I need you to study. So this is actually the template answer on how to answer all the explained answers. So later when we are doing the worksheet questions, you realize that you will keep on need to refer to, these are the two main ones. The boiling melting point answering technique. Can you put a star over here to remind yourself to memorize it? because this is the template answer for all the explained answers. Can you all take note? This is the most important part to study. This one will be good to remember. It is seldom tested, but if they test, this is the model answer. Like if they ask you, can you explain how ionic bonding forms between Na plus ion and Cl minus ions? So if they ask, then this is the model answer. Yeah, so they usually only test ionic and covalent. They won't test on metallic. Okay, then another one that I need you to memorize is this one. So can you put a star for electrical conductivity? Okay, so for these two that you need to study, how to remember it? So mainly is your answer for boiling melting point, mainly 4 key points. Number one, you mentioned to me about its structure. Yep, so if you realize the first point here, can you see that it's like giant ionic lattice structure? The other one, discrete molecules with simple molecular structure. Then the other one is like giant molecular structure. This one is like this one maybe you can change it to it's a metal and exists as a giant lattice structure. Yeah, because for metals, the structure is mentioned over here, the giant metallic lattice structure. Yeah, okay, wait, I missed out the word metallic. Let me add it in. Wait, where am I? Yeah, over here. Giant metallic lattice structure. Yep, so for the first point is to always identify the structure. Okay, so this is point number one. Moving on to point number two, it would be you mentioned to me about the strength and type of bond. Yep, so in this case, it's strong, weak, strong, strong. So only simple molecular structure is weak. So this is the second point. The third point, it would be the type of attraction or the type of bond. So for ionic, it would be the electrostatic force of attraction. For simple covalent, simple molecular, as mentioned, there are two of them. For simple molecular, there is the weak intermolecular and strong covalent bond. But the strong covalent bond is so strong that you cannot break. That's why you just write the intermolecular force of attraction will do wrong. We write down the one that can be broken. Then for the giant molecular, it will be the strong covalent bonds. Metallic bonding would be electrostatic force of attraction. So this is the third point to cover. Next, it would be you talk about the amount of energy. So you will mention that as long as strong, you put large. Weak, you put small. So can you see? You just follow. Strong is large, weak is small. So it will be the amount of energy to overcome. Then lastly, you just answer back the question, is it high or low boiling melting point? Yep, so usually when teacher mark your WA or worksheets, they will usually look out whether you cover all these 4 points or not. So if you cover all the points and then it's written correctly, then they'll give you the full mark. Yeah, so that's why I'm giving you as a template. So later you just copy and paste it in, right? Then you can get full marks down. Yeah, with all the keywords present. Okay, then now we move on to electrical conductivity. Likewise, need to have 3 key points. Number one, you need to mention to me whether is there any mobile ions or electrons. Mobile or delocalized ions or electrons. In case you are wondering, what's the difference between mobile and delocalized, right? Delocalized means it's detached from the original. So it's like, example, if your atom, you lose one electron, then the electron is floating around because you lost from the atom, right? That is called delocalized. If it's mobile, it's not lost from it. Maybe the whole ion is just moving around. So for mobile, it's just the original thing, the whole thing just move around. Delocalized means you pick up. Yeah, so that's why for metallic bonding, it's called delocalized because for metallic bonding is the cation, they lost the electron, then the electron float around. That's called delocalized. But for ionic bonding, they will use the word mobile because the entire ion move around. So need to use the correct key terms. Okay, so let's highlight the key points. For ionic bonding, as mentioned, you use the word ions because it's ionic bonding. Ionic bonding got the word ion, so use the word ion. Then for molecular structure, already mentioned molecules. If it's a molecule, obviously it doesn't have ions, right? So that's why no ions and also no electrons floating around. Next, for giant molecular, it will be no ions, no electrons. For diamond and sand, but then for graphite, you all learn it in school, right? There will be one electron that's delocalized, stuck out from your atom. Then they will float in between the hexagonal layers. Yep, so that's why for graphite, it would be there is electrons that is delocalized. Then lastly, metallic bonding, electron is delocalized. So that means in a way, you can also kind of say that like, if it's ions, you use mobile. Electron is delocalized. Because ion is the whole thing, That's why whole thing is called mobile. But electron is always stuck out from the atom. And that's why electron is usually delocalized. Okay, then, yep, so done with the first point. Next key point you need to mention will be, you need to mention whether can they act as mobile charge carriers or not. So you can either use the word mobile charge carriers. If you find that this term very unfamiliar, right, you can use another term. You can just say that, oh, whether it can carry charges or not. Are you all copying? Yeah, make sure you follow and copy it down. Yep, so another way to describe it, it will be carry charge, which is the same, like you see, charge carrier and carry charge. You just flip the word around, charge carrier, carry charge. Yeah, so it's actually still the same point. So you can follow what your class teacher say. Your class teacher use carry charge, then you write carry charge. Okay, then, yep, so let's highlight the key points. So over here for solid state, because the ions are stuck in the lattice structure, so stuck means they cannot carry the charge around because they are stuck. So that's why we would say that unable to act as mobile charge carrier or unable to carry charge. Then for simple molecular also, you don't even have in the first place, of course, cannot carry charge. Diamond and sand also, you don't even have any ion or electrons. Of course, you can't even carry charge. But graphite can. Then metallic bonding, there's electron that is moving around. So yeah, can also act as mobile charge carrier. Okay, then moving on to the third point. I know space to write below. Okay, sorry, I'm going to be a bit messy. I write on top can because I have no more space to write below. So the third point is you just answer back the question. You just answer the question. Yeah, whether can conduct electricity or not. So for solid, cannot conduct. But for molten or aqueous, can conduct. Yep, so you just highlight the key points. I think for the molten or aqueous, you all know how to color code it also, right? Yeah, so you do it likewise. Done. So these are the key points that teacher will check whether you mention all these points. So if you cover all these points, then I'll give you full marks. So in a way, you just use this template, then all the key points will be in. Okay, so I shall move on since the physical students are like also done. I take it that online students are also done. Okay, so I shall move on. So now let's try and see whether can you apply what you have learned now into the concepts here. Okay, so right now, can you try out the MCQ so that I can at least know like how to attend? Because all of you are like new students to me. Yep, so can you give it a try on the MCQ now? Then later, based on your performance, I can know how in-depth I need to go through for the open-ended. Yep, so you do the 5 MCQ now. Then once you are done, then I'll go through the answer. Yep, do now. So for the online students, can you click the raise hand button to let me know when you are done? Yep, then I'll go through the answer. Yep, so finish up the 5 MCQ. You can refer to the summary notes in front while doing. Can I just double check? Any of the online students here do not have the lesson material for today? So all of you have, okay, because if you don't have, you let me know now so that I can show you the QR code to scan to download the lesson material. By the way, for those of you who are fast, once you are done, right, you can move on to do question number 11. Because 11, sorry, number 6. I'll be giving you to do as homework. Yeah, so that means I won't be going through lah. But at the end of the lesson, I'll provide you the answer key. You can check and see if your answer is correct. And for question 6, you can do it. I won't be going through. Let me go around and just take a look at those who are in class. Okay, I will be going through. I'm not really not sure why I'm going around where did I Reminder again for those online, once you are done, can you click the raise hand button to let me know? So once you are done, then I can go through the answer. Just the MCQ will do. When you're done with MCQ, you raise hand. Question 6 is okay. Question 6 is just like, while waiting, nothing to do, then you do question 6. Yeah, so once you're done MCQ, just raise hand now. I think someone just like came online. For the newcomer, if you don't have the lesson material for today, you let me know. Then I can like give you a call, provide you the lesson material. Yeah. So people, once you are done with the MCQ, remember to raise hand to let me know. Just MCQ will do. Then I can go through the answer. No, just the 5 question, the chem bonding 5 MCQ. Then for those of you who are fast, meanwhile waiting, do question number 6. Hello to the student who just logged in. If you don't have the lesson material for today, you let me know so that I can provide you a copy of the worksheet for today. Then you want to like concentrate and finish it so that I will go through soon. On the periodic table. Let me Okay, so for the lesson material, Jaylin, you scan this QR code. Yeah, so this is the worksheet that's on the screen here. Then Jaylin, once you are done downloading, like can access it, okay? Then maybe can you type it in the chat to let me know? Then I'll remove the QR code. Can okay. Okay, so since like almost done soon, I give you all 1 more minute, then I'll go through the answer. Maybe in the center I can share and use together. Okay, so I shall go through the answer now. Okay, so for those online, can you lower your hands, please? Sorry, my button on lowering hands not functioning now. So maybe can you help to lower it? Thank you. Okay, so I shall go through the answer now. Okay, so for question number 1, answer is A. Yep. So any of you need me to go through for this question? So anyone need me to go through for this question? By the way, for those online, Angela, Elizabeth, and Le Yang, can you lower your hand, please? Okay, so how? Anyone need me to go through this question? If you need me go through, can you click the thumbs up button to let me know? So how? Okay, can I'll go through it. Okay, so for question number 1 over here, they're asking you which one is likely to be true. So for the first one, W, they say it's a simple covalent. So you check. The number here is considered low, right? So if you have low boiling melting point, you totally don't conduct electricity at all, and then it is soluble in water. So in the first place, if you totally don't conduct electricity at all, isn't this very iconic of simple covalent or simple molecular structure? Because they totally don't conduct at all. But then how come soluble? Because if you check your notes, by right, simple covalent structure should be insoluble, right? So by right, it should be insoluble in water. But take note, there are exceptions. So except it would be your acid and alkali, right? Remember your lower set, acid and base topic? Remember that acid, whenever you dissolve in water, what happened? You will form what kind of ions? You will form H plus ions, right? Then wouldn't you have your mobile ions? That's why can conduct electricity. How about alkali? Alkali, when dissolved in water, you will form what ions? OH minus. So you have all these ions. Remember, as long as you have mobile ions or delocalized electrons, you will conduct electricity. And then yeah, they are soluble also. Yep. So that's why in this case, yep, it's soluble in water. Okay, so just be careful lah. So this one is actually an acid or alkali. Yep, so it has these two properties, the boiling point, melting point, and electrical conductivity of simple covalent, but the solubility is different because acid and alkali have exceptions. Okay, then moving on to option B, X has a giant metallic structure. So from giant metallic structure, by right, it should be good electrical conductivity, right? Because metals are usually solid, and solids, metal always conduct electricity, ma. Yep, so that's why in this case, this is incorrect. So that's why this is wrong. Next, for Y, it has same physical properties as silicon dioxide. Okay, so let's check. For the melting and boiling point is high. Your electrical conductivity is good. Oh, this one you have to be careful. Silicon dioxide is actually the main component in sand. So then if you check for sand, you refer back to the notes. Let me scroll up the notes. For sand, over here, electrical conductivity for sand is here. It doesn't conduct electricity. That's why for this statement here, it should be do not conduct. So that's why this part here is incorrect. So it is poor or totally don't conduct at all. Yep, so that's why Y is incorrect. So Ethan, okay, right? Okay, then next is for Z. Z is held together by electrostatic force of attraction between ions. So ions means they are trying to say it's ionic bonding. So let's check whether the traits of Z is it of ionic bonding. So it's high. Yep, you check the table, the summary table. Yes, ionic bonding is high. Electrical conductivity is low and low. No, this one actually should be good. Let's check. So let's check the boiling melting point and electrical conductivity. So based on the summary notes above here, the boiling melting point for ionic is high. Yep, it is correct. The table is correct. How about electrical conductivity? Can you see for liquid? Because one is liquid, you can flow ma. So if you can flow, that means will conduct electricity. That's why in this case, it will be this part is wrong. It should be will conduct. Yeah, that's why Z is also incorrect. So in the end, you only left with option A, which is because of the exceptions. Yeah. You all follow and copy down all the explanation? Yeah, so why I'm going through the MCQ is because later the answer key I give you is just A, B, C, D. Yep, then don't have explanation. So this is the explanation, so should copy it down. Yeah, that's the purpose of tuition, right? Tuition is like to get the explanation. If not, you just buy assessment book, then just study on your own. Yeah, also got A, B, C, D. So you come for tuition is for the explanation. Yeah, so must write the explanation. Okay, seems like you are done copying. So I shall move on. Pinglin, you done, right? Okay, then moving on to question number 2, answer is B. Anyone need me to go through? If you need me to go through, can you click the thumbs up button? So how, physical students, anyone need me to go through question 2? Yes, okay, then we go through question 2. The chemical equation is as shown. A test on electrical conductivity showed that both reagent and the resulting solution all can conduct electricity. So they are asking you what causes the electricity conductivity. Okay, so for here is metal. This one, you just go and check the answering technique for electrical conductivity. So let's check for metallic bonding. Okay, so let's go back to the notes. For the answering technique for the electrical conductivity. For metallic bonding, it is electrons. So that's why, let's take a look. Yes, so electrons, correct. Okay, then moving on to acid. You all learn from lower side, right? That acid always dissociate to form what thing? Must H plus ions, right? Yeah, lor. So that means it's by ions. And not only there's H plus, nitric acid, you based on the chemical formula, nitric acid is HNO3, that means you also got your N ion, right? So yeah, both will conduct electricity. Cause remember ionic bonding? So ionic bonding is where you have ions that can carry charge. Yeah, because the mobile ions can act as mobile charge carriers. So yep. So one interesting thing I would say is that for acids and alkali, okay, mainly for acids lah. Acids, you realize all of them are non-metal. So actually for acids, when it is dry, it is actually covalent bonding. Yeah, so example, like you see HNO3, non-metal, right? Non-metal, isn't it covalent bonding? Or maybe you look at HCl or H2SO4. As long as all the acids, they are all non-metals, lah. So non-metal, covalent bonding. But then once it is like dissolved in water, that means aqueous state. You can also class hydrous and hydrous. Not really. Hydrous means you have water or crystallization, but it still exists as solid state. So now I totally make it to become like liquefied, dissolved in water already. Yeah, so hydrous is solid with water crystals inside, but it's still solid state. This one is aqueous state, so different state. So for dissolved in water, you realize that acid will always form the H plus ions ma. And wait, actually this one I should write as explanation. Yep, so H plus ions. Ions means it would be ionic bonding. So take note, okay, that acid and alkali, they can have dual personality. A bit rare, because usually most substance is like, you base on, metal plus non-metal is ionic. But this one is like non-metal and non-metal can be ionic also. That's why just now at the start of the lesson, I was saying that the guideline of like metal, non-metal, this is just a general guideline. There are exceptions, which is in this question here. Yep, okay, then next. Yep, so for this part over here, it will be the ions. Ions can act as mobile charge carriers. Then next part over here is salt. So for this salt, it is actually made up of, you can tell, right, that NO3, by right must memorize, my NO3 is charged minus. Then M over here is a metal. Metal usually form cation, right? Because metal is on the left side of the zigzag line. So left side is usually plus charge. So yeah, plus minus. That means it's ions. So yeah, that's why B is the answer. Okay. Okay, so do you all follow and copy this in? Yeah, so make sure you copy it down. Okay, so let me re-explain again on the difference between hydrous and aqueous. So, okay, example, if you say hydrated salt, so if you say something is hydrated, it would be solid state. So hydrated, it would be, let me give you an example, like the copper sulfate. Back then when you were learning the experimental design, then we would say that, copper sulfate can be used to test for the presence of water. Why? Because if there is water, it will become blue color. Why? Because it will form this thing. We call this thing as water or crystallization. We'll go through more on this water or crystallization later when we reach the mole concept. Yep, so hydrated means it's still solid, it's like still powder, still crystal form. So it's still like hard, solid. But as compared to aqueous would be you dissolve in water. So that means your state is no longer solid, but it's called aqueous state. Okay, so it's like you dissolve in water. So you get what I mean? One is like solid state, one is aqueous state. Yep. So this is like wet, while hydrated is like it's the solid form lah. But inside got some water or crystallization. So Alva, is it like clearer now, or do you want to further clarify? All good, huh? Okay, can. Okay, so I shall move on to the next question. Question number 3. Okay, so who got this question wrong? Need me to go through? So if need me go through, you click the thumbs up button. Okay, can, I'll go through. Okay, so actually this one, right? That's how I teach my class is my class student usually can get this right lah, because I teach them that actually, right, once you see ionic or covalent, right, the tips is you just choose polyatomic ions. Then can already. Yep, so what is polyatomic ions? Polyatomic ions refer to many circle. Okay, so poly means many. Atom, just now remember I told you atom versus molecule. Atom is singular, one circle. Molecule is plural, right? Many circles. So that means they are trying to say that many circles. So for example, like all the ATEs of sulfate. This one got many circles, right? 1S and 4O. So that's many circles, so that's polyatomic. Or like carbonate, 1C plus 3 O's. That's 4 circles. So yeah, many circles. And then ions. Ion is charged. Yep, so it will be all your ATEs. So all these chemical formula, by right, need to memorize it because it's concept from lower sec. Yeah. Okay, so once you choose polyatomic ions, that's the answer there. Carbonate, done. This is the shortcut tips that I teach my class so that you know they can do the WA faster. Okay, so the reason why choose polyatomic ion is because polyatomic ions, do you realize they are mostly non-metals? You see, they are like non-metals. So that means once you have metal plus non-metal, isn't this ionic bonding? And then next is within the polyatomic ions, because they are all non-metals, isn't this covalent bonding? Like the S is covalent bonded to O. The C is covalent bonded to oxygen. So yep, it would be covalent bonding. So you see, ta-da, you have both ionic and you also have covalent. You have both. That's why they will have both. So that means as long as you choose polyatomic, it will cover both. Yeah, so that's the tips to do it fast. So you don't need to try out one by one. Just choose the polyatomic will do. Oh yeah, polyatomic actually over here, I missed out one more, sorry. There's one more, NH4 plus. This one also many circles, right? And then there is charge. Yeah. So as long as it's a cation with another anion, it's still ionic bonding. So take note that, for example, right, it's just extra, let me just link it a little bit further away, but good to know, is that, for example, like ammonium chloride, for example. This one, you need to know that it has both ionic and covalent. But if you look at it, usually ionic, we always say it's metal plus non-metal. In this case, got metal or not? No metal, right? But then how come ionic? The reason is because ionic bonding is not just restricted to just metal, non-metal. That's why just now I was saying that on the very first page of the notes, over here, how do you classify? This is just a general. You need to know the specific exceptions. So that's why I purposely pick this question so that I can highlight to you that, yeah, there are actually exceptions. So the exception would be, like in this case, why is it ionic? It's because NH4, based on what you learned in lower sec, NH4 is plus charge. Cl, if you check periodic table, is minus. As long as you have ions, right? Positive ions, negative ions. Yeah, so as long as you have ions, it will be under ionic bonding. So it's not just metal, non-metal. Can be cation and ion also can. So I would say ammonium is the only one exception. This is the only one exception where non-metals can be ionic. But all the other questions, it would be as long as got metal, then yeah, it's ionic lah. This is the only special case where non-metal yet can be ionic, as well as your acids and alkalis lor. Yeah, so your acids, remember your acids can also be ion. So take note, so it's only ammonium and acid, they can become ionic bonding. Yep, then covalent is very obvious because all of them are non-metals. Non-metals, that's why covalent. No? Okay, so let me write out the explanation. Because it exists as ions, covalent is because non-metal plus non-metal. So this is usually the type of question that school will set to distinguish between like the A1, A2 student or like the 4.0, 3.6 student. Because like, do you know the small details like these exceptions? Yep, so take note of this. Okay, so I shall move on. You're done copying everything, right? Just now I think I heard someone like entered this Zoom meeting. If you just join this lesson and if you do not have the lesson material, can you sound it out to me in the Zoom chat? Then I can provide you the lesson material for today. Okay, so done copying, right? Peyton, you done? Done, Okay, then we move on to question number 4. Okay, so any of you need me to go through this question? Okay, I see you're not here. Okay, can. I will go through. So over here, they're asking you what type of bonding is this? So remember, isn't this like your the sand, correct? Because the sand isn't it like the similar to sand, right? Sand is like SiO2 ma. So isn't this covalent bond? Or you don't base on sand, you just base on like oxygen is non-metal. Then silicon is also non-metal. So non-metal plus non-metal, isn't this covalent bonding? So that's why it's covalent. Then next is, do you see over here all the charges? So once you see charges, you see ions, right? Ions means ionic bonding. So cause ionic bonding, the name comes from ions. That's why it will be ionic bonding. That's why it's both. Yeah, so write in the explanation. Yeah, copy it down. By the way, for those online, if you find that the lesson pace maybe a little bit too fast, then anytime that you feel that you might miss, you can just always take a screenshot. Okay, so I shall move on. All right, okay, so let's continue on to question number 5. Anyone need me to go through this question here? Need me to go through? For those online, if you want me to go through, you click thumbs up. So how? Okay, can, I'll go through. Okay, so for question number 5, they are asking you the total number of electrons in the covalent bond joined to phosphorus. So first, go and find where's the phosphorus. Check periodic table. Phosphorus is letter P. So then now, how many covalent bonds are there? You count how many lines? 1, 2, 3, 4, 5. Do you see there are 5 lines? And do you know that each line is one covalent bond? And how many electrons are there in one covalent bond? Covalent is the sharing of electron, right? If one side share, the other side also must share. So one covalent bond got how many electrons? 2 electrons. Yep, so that's why in this case, if you have 5 covalent bonds, that means you will have how many electrons? How many? You have 10 electrons. Yep, so that's why the answer is 10. For ionic, they wouldn't use this kind of line. This kind of line is for covalent bonds. Yeah, ionic don't have this kind of lines. Yeah, hello Alicia. Yeah, can you scan the QR code to get the lesson material? When you are done, can you let me know? Okay, then meanwhile waiting, you want to do question 6? Because I said that question 6 I won't be going through. So Alicia, you done? Can I remove the QR code?
Yeah, I'm done. Thank you.
Okay, no problem. Okay, so let's continue on to the open-ended. Okay, so for, wait, this is the answer, right? Okay, let me remove the answer. Almost accidentally flash the answer. Okay, so for question number 11 is very manageable. I leave it to you to do it. At the end of the lesson, I'll give you the answer key. Okay, so moving on to question number 7 over here. Oh, wait, before I move on to 7, just wanted to let you know that, okay, so for question 6, right, because all these are just like state question, all these are easy, you just take the answer. So it's straightforward answers. So this one over here, let me go through. Take note, this is a kind of question that is super commonly tested. Yep, so can you all put a star to let yourself know that this is very commonly tested. Most likely will come out in your WA lah. Yep. So you realize there's a lot of worksheet that keep on saying in terms of bonding and structure, explain. In terms of bonding and structure, explain a lot. There will be a lot of such questions. So whenever they ask you to explain, and can you see conduct electricity? So what should you think of? The answering technique. So can you write down? Okay, usually in class I write AT lah, called shortcut, okay? AT means answering technique. If you don't understand AT, you can write out answering technique, okay? So refer to the answering technique. So come, let's take a look at the answering technique. So it would be, you put electrical conductivity, which is this table, the last table, can you see? So first is you just need to identify what kind of bonding, then you copy the respective column. Is it the first column, second, third, or fourth column to copy? Okay, so I'll leave it to you to complete this question on your own, because you can just copy from the answering technique. Okay, so then make sure that in your answer, take into account the bonding and the structure. So in my answer, I've actually, in the answering technique here, I've actually covered the structure, like you see, like lattice structure for this, but some of it don't have structure, right? What you need to do is, okay, metallic bonding have, but like for the simple molecular and giant molecular, if you realize it, they never include the structure and bonding as requested by the question. You just take a look at the earlier table. Then the earlier table, I would have mentioned that what kind of like structure and bonding, then you can just copy law. So like covalent, you write down like weak intermolecular force of attraction. Then like for the giant molecular, you can just copy accordingly. Yeah. Okay, so that means you just combine a few answers together. You copy the table structure. Then can you see the structure? Then bonding. Can you see? So you copy the structure and the bonding first, then the answering technique. Ah, yes. Yeah, can. Okay, so that's how you get the answer. So you copy from page 2, then page 3. So can you all write it in to remind yourself later when you do it on your own? Refer to page 2 and page 3. So this one, you refer to page 2. Then the answering technique here, you refer to page 3. So you need to combine two answers together. It is ionic and covalent. They shouldn't give you a double question. It should be. This one is double. No leh. No, it's not. Same as question 4. Let me take a look. Okay, so true. Okay, so let me go through this one here. So for structure D, yep, you do see covalent and ionic. But if covalent cannot conduct, but if you got ionic, then what happens? You become from cannot conduct become can conduct, right? So you write in terms of can conduct. So that means you should be referring to the ionic bonding answering technique. So you write now about the ionic answering technique instead. Okay. Okay, so have you written down all the hints so that you can write out the answer on your own at your own time? Done copying the hints, right? Okay, so then let's continue on to the next question here. Question number 7. I think I heard like someone just logged in, is it? If you just join this Zoom session and if you need the lesson material, you let me know, then I can show you the QR code to download the material. Okay, so this question I will go through. So the question says, the graph shows the melting point of some elements and their oxides in period 3 of the periodic table. So yep, these are the ones. And part A, they're asking you to describe the trend in melting point of the elements across period 3. Okay, so one key point to take note actually is something that you need to know from lower sec actually. It's a skill that I've been teaching from my sec 1 students all the way until sec 4. You need this skill. Is that whenever they show you graph or table, what do you need to do? Correct. Yeah, you always need to put the data. Yeah, so you need to like tell me the numbers. Yeah, so you need to put the data. Okay, so over here, they're asking you to describe the trend for period 3. So what do you realize for period 3, the elements? Okay, so first is, if they say element, which graph are you supposed to refer to? Is it the dotted line or is it the solid lines? Which one should you refer to for elements? The solid line, because element, based on what you learn in lower sec, so you see your lower sec concept very important. I cannot forget everything. So for elements, it is same type. Just do a quick recap. As compared to compound, compound would be different type. Something like, for example, water. Water is H and O, right? Different type, that's compound. Then same type or like one type, maybe oxygen gas, O2, both are O, right? Same type, that's element. So that's why this time around, same type also called one type. It would be the solid line. So you should be referring to this line. Okay, so now we are supposed to describe the trend. Take note, it's just describe. So whenever they ask you to describe, you just need to mention whether like it increase, decrease will do. That's called describe the trend. There's no need to explain. So that means I shouldn't see words like what attraction, electrostatic force of attraction and stuff. Just need to tell me increase, decrease will do. Okay, so now so usually for graph, best is you chop the graph up into different segments to explain. So now where do you think I can chop my graph at? MG. But this is still continuing upwards, right? So you can, okay lah, but true lah. Because this part here is not increasing. Okay, can. So yeah, you chop at MG. So increase, then constant, then you chop again, then increase again. Then like what Singy say, yeah, until SI. Then from SI, where do you chop it next? P. Then where do you chop next? Also in the end, oh, there's no one specific general trend. So that means you really need to explain every single section. So for this one, it's a bit long-winded lah, because there's no like consistent trend. Okay, so then what you need to do is you just explain section by section. No? So you just mention that what happened to the melting point. So for the first part, how would you describe? Increase. Then the next part would be remain the same. Then next part would be increase, then decrease, then increase, then yep. So can all of you write it in? Yeah, copy it down. Yep. Then next it would be add in all the numbers. So you say that increase from this one a bit hard to gauge the numbers. This one you can say that it's like wow, a bit hard to estimate. Okay, so I think in this case, you can't really code the data because it's like in the middle of nowhere, you can't really estimate. Yeah, so the coding of data, maybe you add it in, but if possible, you code the data. Like, you know, those that is exactly at like 500, then that kind you can code lah. But for this question, it's tough to code, so no choice lor. For this question, I think you can't code. Yeah, because it's not at an exact value. But if it's like table, you know, table, they give you the number very obvious, right? And that kind you need to code. Or if the graph really stop at a particular line, and that kind you need to code. So you try to always code whenever possible. Okay, so I shall move on. So you just write it out in proper sentence will do lah. Then that will be your answer. So I leave it to you to write it out on your own at home at your own time. Moving on to part B. So you see, again, it's the same type of question. So after a while, you can kind of like predict what kind of question will come up for your WA. It's always with reference to structure and bonding. Okay, so then, yeah, so make sure that you account for structure and bonding in your answer. So this time round, structure and bonding means you refer to the table again. No? So that's why I said the tables are very important. So structure is this one, bonding is this one here. Okay, so just refer to page 1. Okay, so you write it in. So refer to page 1. So this notes page 1 for the, okay, wait, I think you should write on top here. So this one is notes page 1. And then they ask you to explain why it has a high melting point. So you see, whenever it's explain and melting point, what should you think of? Thank you, Simi. You're answering me. Thank you. Yep. So yep, it would be to refer to the answering technique. Yep. So melting point. Come, let's check the notes. So where can you find the answer from? So based on the notes, can you see? Then of course you need to first identify the correct bonding first. Once you can identify, then you copy the template answer. Then full marks there. Okay, so go and study hard on this. So this kind of question should score. Because this kind is like you just need to put in effort to study, then you can score already. Yep, so this would be notes page 1, page 2. Okay, so let's write it down. I think just now I realized I might have written the wrong page number because I realized the page number here and page number I see here a bit different because there's a cover page. Yeah. So this one, you write down that this one would be the answering technique is notes page 2. Yep. Have you all written in the hints so that you will know how to write it at your own time at home? Okay, so write in the hints. Okay, then moving on to part C, you're done copying, right? So everything that I write, you must write it in. Yeah. So these are the key points that I'm highlighting to you. Okay, so moving on to part C, this question, listen carefully, okay? There's something very important, which is whenever question is like that, they ask you to explain why the melting point is higher. So this is actually a comparison question. So for those of you who are in my class, whenever it's a comparison question, what did I mention? Correct. So whenever it's comparison kind of question, let me just repeat in case you can't hear Helen. Yep. So is that for comparison question, you must always compare point by point. What do I mean by point by point? You know, just now in the tables, right, when I was going through the notes, I highlighted for you all, right, that melting point, you need to cover a few points, ma. Like you need to talk about like the strength, and then you must talk about like the what kind of forces of attraction and all. Yeah, so there are like you highlighted, right, a few points. So those are the points that I'm saying. I elaborate more a little bit. You follow and copy down first. So take note that when you write, you shouldn't write substance by substance. What do I mean by this is that you cannot write one whole paragraph. You write down about the first three oxide. Then another paragraph, you write down sulfur and chlorine. So you cannot like, oh, I just copy the entire, what answering technique for the first substance. Then entire paragraph, sulfur and chlorine. Because if you write it right separately, you're not comparing. So to compare, you need to compare point by point, right? Maybe the attraction versus the other attraction. The amount of energy versus the other energy. And that's why the boiling melting point and the other boiling melting point. So what do I mean by that is, okay, so let's take a look. So for the oxides of the first three, okay, let's take a look at this question here. Oxides for the first three. First, let's identify what type of bonding is it for the first three? Ionic, right? Can you see it's metal and non-metal? So generally, metal plus non-metal, it will be ionic bonding. Okay, so let's write it in first. So for the first three, it would be ionic bonding. Okay, then next, they are asking you about sulfur and chlorine. So for sulfur and chlorine, let's take a look. It's over here. Can you see sulfur with oxygen, chlorine with oxygen? What type of bonding is this? It's covalent bonding. So what I'm trying to tell you is that if you were to write your answer, first paragraph, ionic bonding answering technique. Then second paragraph, covalent bonding answering technique. The 3 marks, you get 0. Take note, it's very serious, yeah, because it's like even your answer everything correct, right? I do see in my students' worksheet is that, sorry, not worksheet, in their test, yeah, in their WA, the answer really perfect, like the student really study hard and then she write everything correctly. It's the same as the answering technique. But because she write one whole paragraph, ionic bonding answering technique. Second paragraph, covalent bonding answering technique. 3 marks is 0, even though it's perfect. Why? Because teacher write that side, no comparison. Because over here, you see, they asking for comparison. So for comparison, you cannot write, like this substance, green one, and then the orange substance. Cannot. You must compare point by point. Yeah, so that's why you need to talk point by point. So let's take a look at the answering technique. So for the boiling melting point answering technique, it's over here. What's the first point? The first point, we should talk about the structure. So that's why you should write down that for the first three is ionic compound with giant ionic lattice structure. Then for the second one, you should write down that they exist as this with this structure. Okay, so that will be your first sentence. Okay, so let's write it in together. So need to compare point by point. So let's write down the structure first. Okay, so for the first three, it will be Na. You just refer to the graph in front. So for the graph in front is Na2O, MgO, and Al2O3. You all know where I get these formula from, right? These formulas are from here. Can you see? Na2O, MgO, and Al2O3. Okay, so I copy these. Okay, then next it would be that. Yep, so first I'll just copy the notes in front. They are ionic compounds with, can you refer to the notes in front? Can you write it in? Yep, you write it in back. Yep, so can you flip to the front? Just continue finish it up. Yep, refer to page 2 of the notes. Can you finish up the first bullet point? So you copy until the word structure. Okay, so after you done copying until the word structure, because it's a comparison question, you should use contrasting words. So you might use the word like while or but to show comparison. So after you are done writing, can you like also indicate? Yeah, so this kind of words is to show comparison. Okay, so then now, like what I mentioned, you cannot continue copy the entire ionic bonding answering technique. You must compare point by point. So now we compare it with the covalent structure. So you see the first point is on structure. So while the other one is SO2 and Cl2O are covalent compounds with, yep, so you copy from the page 2 until the word structures. So that means you just copy the first bullet point. Done copying from page 2. Okay, so you see point number 1, it would be on the structure. So can you also like label it? So you see point number 1, it will be on the structure. Okay, then now we move on to point number 2. So point number 2, if you refer to the notes on page 2, what's the second point? The second point would be the forces of attraction, strong electrostatic versus weak intermolecular. Okay, so let's write these two in. By the way, the blank is for you to answer in context of the question. So you fill in what ions do you see lah. Okay, so then now for this question here, where am I? I'm over here. Yep, so the next point is on the structure. Sorry, on the bonding. Yep, so in Na2O, MgO, and Al2O3, there are strong electrostatic force of attraction and stuff. Yep, so you just copy from page 2. Yeah, this one for SO2 and Cl2O, they are under the simple molecular. Because only the 3 special ones, the graphite, diamond, and sand, these 3 is giant molecular. So usually the rest, if you're not sure, just put it under simple molecular. Yeah, just write everything in. Yeah, to have a more complete answer. Okay, so after you are done copying until the word anion, then now use comparison words again. So up to you. You want to use while also can, or you want to use but also can. Yep, so always use contrasting words. Then now we copy for the SO2 and ClO2. So but in SO2 and Cl2O, ayo, what am I typing? N. Yeah, so you should, oh wait, oh this time around a bit hard to specify, so it's okay, just say cation, anion will do. But if it's only one substance, then yeah, you should specify. So this time around, the blank, like the cation, anion, the blank, you can just leave it lah. Just skip it. Yeah, don't need to specify, because there's too many ions to specify. Can also, yeah, can. So the identifying of ion will be optional for this situation, because there's too many ions. Okay, so then yep, let's continue to copy. So based on the notes, it would be the force of attraction, it would be there are weak intermolecular. Yep, so can you just continue to copy from the notes in front, the table in front? Yeah, so copy from page 2 for the simple molecular column. There will be weak intermolecular force all the way until the word molecules. Stop. So the second point, it would be on the forces of attraction. Can you follow and label it at the side? Forces of attraction. Yeah, label it, label it. Okay, so if you look at the notes, after you talk about force of attraction, it would be the amount of energy, correct? And this time around, since it's comparison, let's use the word larger or smaller amount of energy. Yep, so then in this case, I would say that larger, or you use the word more also can. You use such comparison words again. So the amount of energy required to overcome the stronger electrostatic Yep, so we just compare. Then lastly, it would be Just answer back the question. Lor. So can you also label at the side? So this would be talking about the amount of energy. Then lastly, answer back the question. The question is about the melting point. So point number 4, melting point. Then same thing, use comparison words. Who is higher or who is lower? So for the Na2O, MgO, and Al2O3 will have higher melting point than the other two, SO2 and Cl2O. Yep. Then after you are done copying, can you highlight the keywords like that, this kind of thing, larger or more, higher? All these are all comparison words. Yeah, so maybe can you highlight all of them? Then you can like annotate, like your highlighting means need to show comparison. Okay, so need to use all these kind of comparison words, contrasting words. You have to show teacher that you are really spotting the difference. Okay, so I based on the physical students, they seem to be done. So for the online students, if you're not done, maybe can you take a quick screenshot of what's shown here? Because I am about to clear the screen soon. So if you're not done, you take a screenshot. If not, you left a little bit, you can try to memorize it. Yeah. So I'm moving on in 5 seconds. So people, can you make sure that you copy down all these pink color words? Because all these are the skills that I'm teaching you on how to answer open-ended questions. So need to know all these skills. Yep, so don't just copy the answer. Like, copy the answer, might as well just buy assessment book, then just get the answer key, right? Yeah, so you come here is for the explanation, yeah. So copy down the explanation. Okay, I'm moving on in 5 seconds. If you need screenshot, you take a screenshot. 5, 4, 3, 2, 1. Okay, moving on. Okay, so for the next question here, this one is like from NYGH. Yep, so for this question here, you see 40. So then, wow, it looks like quite complicated. So do you think is it simple or giant covalent? So how do you tell? So what do you think? Is it simple or giant? Okay, so if you're not sure, usually the question will give you hints. Okay, so what you need to do is you continue with the question. Okay, the first one not very obvious, but the part B, they kind of hinted you that the bonding. So if you see poor electrical conductivity, in a way, okay, still I think it's not very informative also. Okay, I think you need to go on to the behind part. They mention high or low boiling point. Okay, this one's still not very obvious also. Okay, so overall, I think they didn't want to give you the hint. Some question they might hint to you, is it simple or giant? Okay, so now you based on what I teach you lor. So just now I was saying that 40, is it considered a lot or not? No, right? So this is actually simple, not giant. So a lot of students get tricked or they see that, wow, like very complicated, then they thought that, okay, it's giant. But actually the answer is simple. Because giant, usually for your syllabus, they tend to restrict it to only those three, which is the sand, diamond, and graphite. Yeah. So this one is actually still under simple. Because in chemistry, below 100 is still quite simple. Yeah. Just like the boiling point, right? Must above 800, then it's considered high. Okay, so for this question, let's do it together by considering the number of valence electrons that boron has. Okay, so first, can you check periodic table? How many electrons does boron have? Can you check the periodic table now? Correct. Let's write down 3. So then they are asking you, what is unusual about the bonding between phosphorus and boron in this? Means what the weird thing. Okay, so let's check. One boron bond to how many? Okay, maybe I zoom big, then we can take a closer look. Okay, so maybe I just anyhow choose one. Okay, so maybe I choose maybe this one or this one. Maybe this one. Okay, so if I choose this one, how many bonds are there? So let's take a look. There's one over here, right? One. Then you link to here. 2. You link over here. 3. Here. 4. Here. 5. So what's so unusual? You only have 3 valence electron, but then what's unusual? You bond to 5 eh. But right, if you have 3, you should only bond to 3, right? But how come you bond to 5? That's the unusual. Because usually only valence electrons is involved in covalent bonding. And people, have you all labeled the 5 bonds? Can you all label it? Yeah, label in your diagram now. Yeah, so that will be the answer. Okay, so I write the answer over here. So the answer for part A, can you directly write it on the line provided? Yep, so you write now, boron by right got how many electrons? So if it's 3 electrons, it shouldn't be bonding to 4 or 5 lah. That's the unusual part. Okay, so I shall move on to the next part. So for part B, in terms of structure, explain why borosperine is expected to have poor electrical conductivity. And again, whenever it's explain electrical conductivity, what should you think of? The answering technique again. Can? So just refer to the answering technique on page 2 of the notes law, the electrical conductivity one. But remember to state the structure. Okay, so 1 mark would be identify the correct structure. Another mark, it would be copying the answering technique. Okay, so this is the mark allocation. People, can you follow and copy down the hints? Yeah, so whenever you read a question, must read carefully. Then you need to answer all parts of the question. Hello, have you labeled it? So structure, 1 mark. Then answering technique, another 1 mark. So sadly, yeah, your answering technique very long, but only 1 mark. But you need to have all the points. Yeah, because there's no half mark. Okay, then moving on. Done copying, right? Copy. I move on already. Okay, moving on to part C. State and explain whether it has high or low melting point. So again, what should you think of? What should you think of? Yep, structure. But actually, this question, they never mention structure. So actually not required. So how? What should you think of? Yes, very good. The answering technique one. Not bad. You pick it up already. Okay, so yep, so refer to the answering technique. Can? Yep, so this one refer to the notes page 2 again lah. Then you write it in law. So the mark allocation will be state is 1 mark, answering technique 1 mark. Okay? Yeah, so make sure you account for both. State 1 mark, explain 1 mark. Done labeling? I shall move on. Done, right? Okay, so moving on to the next part here. And allotrope. Okay, by the way, you all still remember what does the word allotrope means? It's in the chem bonding notes. Do you all remember? Very good. Well, that's the perfect definition. Yep. So allotrope means same element but different structure or arrangement. That means like we would say that this is a I would say that like carbon and diamond, they are allotropes of each other because diamond and graphite both are made of carbon, same element, but then different structure. So different structure means allotrope. So they are saying that they have an allotrope of carbon, which is this one, C60, has similar structure to that. Okay, then they're asking you to predict and explain the boiling point. Since the hint is they have the same structure to borosperine, and borosperine, we mentioned about the boiling point and melting point, right, of borosperine. So this is related to part C. Because if you look at part C is asking you to predict is it high or low. So that means by right, the answer should be the same. Yep, so then in this case, they are asking you based on borosperine, is it higher or is it lower than borosperine? So what do you think? Is it higher or lower? Any idea? This kind is application question. They ask you to predict. So this kind is usually to distinguish between the A1 and A2 students. Yeah. So how anyone is an A1 student here that can tell me what's the answer? Is it higher or lower? Anyone challenge? Okay. Yes, it is higher, correct. But why is it higher? Why is it higher? Higher is correct. No, not giant covalent. Angela, your answer, I think that one is more for advanced chem lah. So today we normal chem, okay, IP chem. Yeah, so that kind of concept not applicable. Uh, but we cannot break covalent bonds because covalent bonds are too strong. So over here, when we talk about bonding now, but we can't break the covalent bonds, right? Because remember, if you refer back to the answering technique, we can't break covalent bonds. Let's take a look at the answering technique. You see, for simple molecular, what are they breaking? They are breaking the intermolecular force of attraction. Because the covalent bond is too strong. So just now I mentioned, right, when I was doing a recap, I was saying it's so strong that you see, I put in bracket. Don't really need to mention about it because it's too strong already. You can't even break it. So the one that we want to break is the intermolecular. Okay, let me give you some hint since your can't really talk.
More bonds to it's more force of attraction.
Yeah, correct. So, okay, I won't say the word more, but true is linked to intermolecular force of attraction. Then yes, Helen, do you want to give it a try? I can't hear you. Close, close, close. You're getting close already. Okay, so what Helen is saying that is it because it's like not small? Okay, so close. Why? Because you imagine if my molecule very small, what's intermolecular? It's between molecule, right? Like inter-house competition means house and house compete. Intermolecular means molecule and molecule track. So this is for small molecules. You compare this one so big, and then I draw another similar one. Equal size, sorry, very ugly. Okay, but anyways, how do you have the intermolecular force of attraction? It's like that, right? So what do you realize? So the bigger the substance, the stronger the intermolecular force of attraction. So actually the correct word to use is not more, but it should be stronger. Can you see? Like Scotch tape, you use so little bit, very weak, right? But Scotch tape, you use, wow, you pull such a long one, wouldn't your Scotch tape be like stronger? So that's why longer is stronger, okay? And why would this be stronger? Because need to explain, so we only managed to predict. But what's the explanation? Because this one is, how would you describe? How would you describe? Why this one is stronger than what I've drawn? Just look. Correct. So there are a few answers. Yep. So one answer, like what the physical student has mentioned, is in terms of size. It's larger size. That's why stronger intermolecular force of attraction. Another answer that Ethan contributed is also correct. Is about the electrons. So if you have like more electrons, yep, then it will also result in stronger attraction. But I think the easier one to visualize would be larger size lah. But both are acceptable. Because larger size means you will have a stronger force of attraction. Because here they say it's a C60, right? 60 is big, Normally, if you compare to like H2O or CO2, only 3 circles. CO2 is 3 circles, water also 3 circles. Those are weaker. Yeah. So this will be the answer. Also, mainly you must have the word larger and stronger intermolecular force of attraction. That will be the answer now. Okay, so I leave it to you to phrase it out on your own. You just need to make sure you have 2 key points. So you just make sure that you have larger, okay, use the word molecular, larger molecular size. So say the molecule is larger size plus stronger intermolecular force of attraction. As long as you have these 2 key points plus you predict higher correctly done. So these are the mark allocation. Okay, so I leave it to you to phrase it out on your own. So Jadine is asking, how do you know it's bigger? Or the number here, 60. Because you compare to the others that we know, like water, carbon dioxide, oxygen, all these commonly known simple molecular structure, they usually have only a big circle, like H2O, only 3 circle, 2H and 1O. Carbon dioxide also, very little circle. This one is 60, so it's like 60 circles, like 60 atoms. So of course, it will be bigger size. Of course, the more atom, the bigger size it is. Okay? Yeah, so done. That's all for chemical bonding. Okay, so next up, let's move on to mole concept. You're done copying the hints, right? I move on. Okay, so for mole concept, it would be these are the formula. Formula wise, I think I don't go through anymore because all this school got teach the basics, right? So all this you all should know. Okay, so let's see whether you understand the concepts or not for mole concept. Okay, so for example here, if I have 1 mole of hydrogen gas, by right, if I ask you how many particles, so take note that whenever question mentioned here about number of particles, you need to answer specifically. Particles can be in the form of atoms, molecules, or ions. Yeah, so don't use the word particles can. Something like if I say, okay, I wear a color shirt, like what color? So must specify, I wear white color shirt, something like that. So that's why you must, so particles is like color. It's a very generic word. So to specify like what color, like white, so atom is like the word white lor. Molecule maybe like yellow, ion maybe like blue. Yep, so you need to specify so that like you know clearly what it is. Okay, so by right, based on this formula, if you have 1 mole of hydrogen, that means you sub the number of moles as 1. Then you multiply by the Avogadro's constant. So what's the number of molecules over here? So what's the answer? Yes. Yep, so that's why the answer is just 6.02 times 10 to the power of 23. Okay, because the working is 1 times 6.02 times 10 to the power of 23. Okay, because you use formula. Can you see? 1 times Avogadro's constant. Then now, this, okay, that's just to let you know, for more concept, this topic, if they omit out stoichiometry, right, this kind of question confirm will come out in your WA. Confirm, I guarantee you, plus shot, confirm will come out one. Yep, which is, because once you remove more concept, actually not much question they can test now. So this is one of the common question that they will test, which is from molecules, change to atom. So now my question is, if I have 1 hydrogen molecule, you all know, right? Molecule is like plural, many circles. So in 1 hydrogen molecule, how many atoms do you have inside? Got 2 H atoms. So that means from molecule to become atom, you double it. That's why from here, from molecules to atom, you have to double it. So the working over here would be, you still go with number of moles times Avogadro constant. So you first find out the original. Okay, so how to solve this kind of question, right? Later I'm going to let you try out an MCQ. So if you understand, means you will be able to do the MCQ. So listen carefully. First, you always go by the original. Originally, hydrogen, you all should know, all the gen, they are all diatomic. Oxygen, nitrogen, hydrogen, all the gen, they are always diatomic. So you need to know that originally, it exists as molecule. So that's why first you do the original version first. Then later, if they were to say atoms, you then modify. So that's why you first go and solve as per formula, you solve for hydrogen molecule first, okay? Molecule. After you solve for molecule, you then see in 1 molecule got how many atoms. Then you then multiply accordingly. That's why now the working would be, you take this number here, the 6.02 times 10 to the power of 23, you go and times 2 lor. Yeah, then you press the calculator, or if you can mental sum, good enough, then it would be like this. Okay, because you get 12 times 10 to the power of 23. Then 12 will change to standard form, become 1.24. That's why the power became 24. Okay, then next part over here, what's the weight? So weight is the mass, right? So mass, you look at the formula here. So this time around, you have moles, right? How to find mass? You take mole times mR. So this one is also known as mR. What's mR? You just check the periodic table bottom number. Yeah, because in the periodic table, the bottom number is the mass number, right? Yep, so mR is always known because can just check periodic table. So you check periodic table, hydrogen is 1, correct? So that's why it's 1 mole times, there's 2 hydrogen times 2, so the answer would be 2 grams. Oh, thank you. Okay, let me edit. 1.2, yeah, 0.4. Yeah, thank you. Yeah, so can you change it? Sorry, I read wrongly. I missed out a 0. Okay, then continue on. This time round, 1 mole is how many DMQ? So take note, this one is for gas only. So that means for solid, liquid, cannot use this formula. This formula is for gas. And need to know the conversion. Okay, so from DMQ to CMQ, you must times 1000. You know the conversion, because usually question like to give you in the wrong unit. Then you need to convert to DMQ. So from CM to DM, you divide by 1000. Okay, so then for this question here, let's calculate. So mole is 1, right? 1, then must times 24. So the answer will be 24 lor. Can? Okay, so now your turn. Can you finish up the rest of the 3 tables? Concept is likewise. Yep, complete the table now. Yep, finish up the 3 tables now. But you must know that all the gen, remember I teach you in lower sec at the time, all the gen are all diatomic. So hydrogen, oxygen, nitrogen, they are all 2. Correct. No exception. So mini is the L shape. Remember the L shape? The L shape from OF and group 7. Which one are you saying?
In grams.
Because in chemistry, mass is in gram. If you take physics, mass in physics is kg instead. Like that. Yeah. So different size, different unit.
Well, that's what extras.
Okay, so for Alva's question, you're asking for atoms. Why isn't it Avogadro's constant divided by 2 for which one? Molecule, atom, gram, DMQ? I think it should be like first or second, right? Molecules, molecules go to atom. Because if you were to draw out for hydrogen, hydrogen is like H. So if remember I was saying molecule is plural, atom is singular, right, at the start of the lesson. So like that is called a molecule. Individual circle is called atom. That means one molecule is made up of 2 atoms. Because one circle is atom, another circle is atom. 2 circle combined become plural is called molecule. So one molecule is made up of 2 atoms. So can you see from molecule, if I want to convert to atom, is 1 times 2 to be able to get the number 2. That's why from molecule to atom, molecule to atom is times 2. Can understand or like you still don't quite understand? Yeah, okay. People, quick, finish up the table, then I can go through the answer. So for Yushen's question, for the waste section here, you're asking, why isn't it number of moles times mR is not 2 grams? Because if you check periodic table for H, the number is 1, right? But you need to know that all the gen, they are all diatomic. So hydrogen, oxygen, nitrogen, all the gen, they are all diatomic, including group 7, then called halogen. Yeah, they are all diatomic. So that means they always exist as 2. That's why hydrogen, if it's 1, 2 of it, 1 plus 1, you get 2. So that's why the MR over here is 2. Something like, if I change my question to like carbon dioxide, then wouldn't you put your MR as C plus O plus O? Yeah, so the MR is usually you include all the atoms mass in the periodic table bottom number. Yeah, it is relative, and then that's why it doesn't have a unit. Because relative is like ratio. Ratio don't have unit, like example 2:3. Don't have unit. Yeah, so that's why MR don't have unit. But molar mass, because they use the word mass, that's why got the unit of gram. Is that what you're trying to ask? So that's why for this part over here, you just times the MR. So for hydrogen, you check the periodic table is 1, and there's 2 of them. So that's why it's 2. So that's why you just take number of moles times 2, which is 1 times 2. That's why the answer is 2 grams. So Yushen, is it okay, or do you want to further clarify? Can okay. Anyways, any of you, if you have any questions, you want, you can stay back after class. I can like, address it with you. Okay, so I shall now go through the answer for the second one. Okay, so how to answer for this question here? So this time round, you need to deduce how many moles. So now work backwards. So in this case, you need to know that if this one become ions, what kind of ion will we form? Based on the chemical formula and the chemical name. What kind of ions? What's the chemical formula for the ions? Correct. You will have like Fe3 plus, Fe3 plus, and O2 minus, O2 minus, O2 minus. So total, how many ions do I have? You have 5, correct? So if you have 5 ions, that means how to get this number of moles is always based on here, I must times 5, because this is one compound. So that means, in other words, one compound has 5 ions. That's why, do you realize from compound to ions, I times 5. That's why from compound to ion, I times 5. That's why if you work backwards, you divide by 5, the answer here will be 3 moles. This kind of question confirm will come out for your WA. This kind asking you number of moles and number of ions. This kind of question is the only thing they can ask, because no more stoichiometry now. Okay, then next. Cannot get it, is it? Not tested for MIGH. They're not testing stoichiometry. They only test on mole concept. Yeah. Don't have stoichiometry. It accepts stoichiometry.
Yeah.
Okay, then for the next part over here, this time around is not mole already. Can you see earlier on is mole, now is not mole. So that's why over here, how do you do? So if you want the particular ions, remember ions is like particles, right? That means you use the Avogadro's constant. So that means in this case, you use this formula. So number of moles you have already, right? The number of moles is 15. That's why you put in 15 times this. Yep, so after you put 15 times in, then what number would you get? Yeah, correct. Thank you, Simi. Okay. Okay, then continue on. So what is the mass? So mass, you refer back to the formula. So for mass is over here. Mass is mole times the MR. So in this case, what's the mole? Is 3 times the MR. So we go and press calculator lah. 2 Fe and 3 oxygen. What's the total MR in the periodic table? So then in this case, it would be, you guys count. Just mole, which is 3 times MR. So Jaylin is asking, why is it a compound? Compound, based on what I went through just now, element versus compound. Element is same type. Compound is different type. So Fe and O, 2 different type. That's why it's a compound. Or you don't go by compound, just based on 1 Fe2O3 inside got how many ions? So if I write as 1 Fe2O3, inside got 5 ions. So if you find compound confusing, you can change it to Fe2O3. So class, what's the answer for the mass over here? What do you get? Again? 478.8. Can I double check with the rest of you? Do you also get the same answer? Is it the same? Of course, my answer key is like 378. I don't know whether is it answer key or is it Simi's type wrongly. Can I confirm? Can more of you press the calculator? It's 478. Okay, that means it's answer key error lah. So 478.8. Okay, so in case you still find it confusing, let me use another perspective to explain to you, see whether will it be better. Okay, so another way of explaining is the way that I normally explain to my class. I always use this example, 0.5 moles of H2SO4. So if I were to ask you, what's the number of moles of H plus? So what I will do is, you always copy down the number shown. So I always write down 0.5 first. Okay, so that's why for this question, you see, you must write. So how to get 15 over here? I will actually write the number of mole given in my original question first. So you see, I write 0.5. Here, to get 15, I also write the number 3 first from the question. Then times what thing? So you can check inside got how many H plus. So now let me break it up. So H2SO4 means H plus, H plus. You don't go and break S and O up because in lower sec, you learn that SO4 is called sulfate, right? You cannot break it up. It's because the entire group is called sulfate. Yep, that's why you write as SO4 2 minus instead. Then now, how many H plus? I see that there are 2. That's why I times 2 lor. So this is 1 mole. But if question, instead of asking number of moles, I ask you number of H plus ions. Remember, over here is ions. Isn't ions like particles? Because just now remember I told you, particles got 3 types. Got ion, molecule, atom. If you don't know what I'm saying, you refer to the top. Just now we did write it down. If you copy when I asked you to copy lah, okay? So over here, I did ask you to write down, right? Particles got 3 arrows. Do you see in your own paper? Particles got ion, molecules, atoms. So that's why if they are asking you in terms of ions, that means they are asking you in terms of particles. So then, if it's number of particles, based on this formula here, and then number of particles, you need to use the Avogadro's constant. That's why for this question here, you write so the formula is number of moles times the Avogadro's constant. So that's why the working will be, what's the number of moles for H plus? Then over here, can you see? Moles of H plus. Okay, let me color code it for you. Then moles of H plus. Moles of H plus. That's why I sub in the number 1. Then times Avogadro's constant. So take note that when you want to use the Avogadro's constant formula, you cannot immediately just, oh, I see what number I put it in. You have to go and interpret one step first. So step 1 is always this. Step 2, you then can use Avogadro's constant because you always need to check what they are giving you. So like if they give you earlier on, if they are giving you in terms of molecule, then yeah, it will be the exact same number. Because if they give you molecule and they also ask for molecule, there is no need to go and times like 2 or times 3. Only when it's a question on molecules, but they ask you on atom. And then that's when you need to interpret law. In one molecule, got how many atoms? That's when all your times 2, this kind of thing come in. So something like for this question here, is because they have inside got 2 ions. That's why you know 2 H plus, that's why you have to times 2. Can? Yeah, like that. Okay, so then can you all give it a try for the next one over here? So what do you all think is the answer for this part here? Yeah, so fill out the third table. By the way, just to let you all know, from the way I see, right, I might overrun like 10 to 15 minutes. Yeah, because this is my first and last time seeing you all also. Yeah, so I need to at least like clear everything that I need for this worksheet. Yep. So if any of your parents, like for the physical students, if your parents are fetching you, maybe you want to drop them a text to let them know that lesson will overrun a little bit. Yeah. So we'll end about 10 to 15 minutes later. Okay, so if you all come up with the answer. So anyone managed to solve it? What's the number of moles of ions? Bell? 2.7. Again? 2.1 also not correct.
Because one
How many ions are there? Can you break it into ions? For what ions? Can you say out the formula? Okay? No. Can you tell me? Okay, so what ions? Can you like let's label out the chemical formula of the ions? Got what ions? Okay, no what charge? 2 plus, correct. Because SO4 is 2 minus lah. And then which is the next ion? Correct. Then water. Water is covalent bonding mah. There's no ions, right? So it's just H2O. Water is covalent bonding, right? Non-metal plus non-metal is covalent. And remember I mentioned covalent don't form ions. Only ionic bonding then form ions. Covalent bonding form molecules. Remember? Simple molecular structure. Giant molecular structure. Yeah, so it's always molecule. So how many ions? There is only 2 ions, right? So in one of this, like you see over here, in one of this H2SO4, there's 2H plus. That's why we went to times 2. So you see what I did was I copy the 0.5 first. So now my working will be I copy the 0.1 first. Okay, so you see the first step. You always copy the number of moles. Then you go and see inside got how many? Inside got 2. You times 2 lor. So inside here got how many ions? Got 2. You times 2. So the answer is 0.2. Can understand? Rian, you understand what's going on? So that means you just follow this template where you always copy down the number of moles given in the question. Then you go and multiply based on how many there are. Okay, so it's always copy the moles, then multiply how many ions there are. Okay, then over here, so for this case over here, how many oxygen atoms do you see? How many oxygen atom count carefully? Here got how many? 4. Then here got how many? There's 9 oxygen. So the working is, again, always copy the question number first. Can you see? Then the 0.5, always copy in first. Okay, so I copy in 0.1 first. Okay, first step, always copy the number shown in the question. Then times, accordingly also here is like 2H plus. That's why I times 2. Here got how many oxygen? Got 9 oxygen. So you times 9. That's why the answer is 0.9. Can understand? Getting the hang of it? Yeah, so it's always the same style. You always copy the question number, then you multiply accordingly. So for Jaylene, you are asking about why need to times 2 because in this substance, when I break it into ions, I can see that there are 2 ions. Just like over here, you see, for H2, I can see that 1 ion, 2 ions. So 2H plus ion, that's why I times 2. So you always have to times based on how many you see. So if question asks for ions, I see 2 ions, I times 2. This one, they asking for oxygen atom. So oxygen atom is 4 plus 5, 9. That's why I times 9. So you always times how many you see. Okay, then the next part is mass. This is easy. Check the formula above. Mole, how to convert to mass? Yeah, so you take number of moles times mR. Just press the calculator. So what's the answer that you get? 18, everything, including the water, you got include the 5 or not? So small, man. Maybe can another person also calculate out and can I confirm? Is it like my answer key wrong or is it like 24.96? Is it? You'll get the same answer? What do you get? Why Xingtian get 25? Cannot be there. It should be decimal place there. So I assume that 24.96 is correct, is it? Can you press the calculator and let me know? Go and plus. So you check periodic table. Cu is how much? S is how much? 4 oxygen how much? 10 hydrogen how much? 5 oxygen how much? Just press the calculator for the MR. Is it? You also get 24.96? Oh, I see. Okay, thanks, Yushen, for the explanation. Oh, because for Xingtian, you write 25 is because you round off to 3SF, is it? True lah. Usually for chemistry, final answer, we round off to 3SF. So, yep. Can write as 25. Yep, 25.0 also acceptable. Can. Okay, then moving on to the last one. You try on your own. Okay, I'll give you the answer key. You can check to see whether you know after I went through 3 liao, can you do the last one on your own? Okay, you give it a try ba. Okay, so moving on to the next page over here. More formula. So there would be concentration formula. And one good thing about concentration formula is don't need to memorize formula. Why? Because you just look at the units will do. Oh, not tested. Okay, but I will just go through because there are variety IP school students in this session today. Yeah. No problem.
Wait, it's not.
So for concentration, anyways, even not tested for WA2, still tested for EOI, right? It's still part of syllabus, so I think no harm learning lah. Yeah. Okay, so for concentration, one good news is that the formula don't need memorize cause you look at the unit. If the unit is mole per dm cube, that means they are saying that the formula is mole divided by dm cube. So that means number of moles divided by dm cube. Dm cube, isn't it volume? Then you see, that mole divided by volume. So this is the formula that is good because you don't need to memorize. Same for the here also. So take note, concentration got two different units. So you have to read the unit in the question given carefully. So this is gram per dm cube. And for concentration, if you look at the unit, gram. Gram, isn't it mass? It means gram divided by dm cube. Dm cube is volume. Ta-da! Done. Yeah, so the formula is just from the unit law. Yeah, so don't need to memorize. Okay, so over here, this one is similar to just now I went through. Remember just now I went through this 0.5 mole of H2SO4. Then I ask you number of moles of ions, right? Isn't it exactly the same? Then the question is exactly the same. Then I give you moles, then I ask you moles, and then ions. Okay, so you refer to just now the example to fill this in, just that they got extra concentration. You give it a try, you can check your answer with the answer key provided. Okay, so moving on to the next part here on empirical formula and molecular formula. Need to know that empirical formula, this is how you present your answer. So it's always the standard 4 rows. First row is always given in the question. So the question will tell you, how many gram or how many percent. And sometimes the question like to be a little bit indirect. What's happening? Maybe like they tell you, okay, carbon example, if I say carbon, I got 20%. Hydrogen, I tell you 20%. Then I keep quiet for oxygen. Like I never tell you how many percent for oxygen. So what do you think is the percentage for oxygen? It will be 60. Because if I told you 20-20, they must add up to 100, right? That's why it will be 20-20, 60. So even if question never tell you, you need to know that percentage always add up to 100. Okay, then next, can you write down like to know that how to know what number to fill in? So for the first row, you always fill in based on what's given in the question. You copy it down. Yeah, follow and write it in. Next, AR. AR would be the bottom number in the periodic table. Then number of moles based on the formula earlier on. Moles is mass over mR, right? So that's why you take the first row divide by second row. So that means the number in the first row divide by number in the second row. And press equals. Then lastly, for simplest ratio is you take the third row, which is this row here, the third row number, you go and divide by the smallest number in the third row. So that means like maybe here got like 0.5, 0.2, 0.2. Then you just take everything divided by 0.2 because 0.2 is the smallest. Yep, then you round off to whole number. Except 0.5. So if it's 0.5, right, what you do is you go and times 2 to all numbers. Yeah, because 0.5 is exactly in the middle. You should not round up or down. So if it's like example, if it's 1, 1, 1.5. Okay, so that means for the 3 columns, I get simplest ratio 1, 1, 1.5. Use everything times 2. So it should become 2, 2, 3. Clear? Okay? Yeah, so only 0.5 you don't round off. You multiply by 2 instead. Then next, for molecular formula, what you need to do is you need to convert all the alphabets into number. So for example, right, if I say that my chemical formula maybe is like I get maybe it's C H 4O to example just anyhow put some random numbers in. Then now I ask you, can you calculate the molecular formula? So what you need to do is you have to make all, so you just make all of them to have letter N. So what you do is you put C N, H4 N, O2 N. That means you just add all the letter N in. So after you add the letter N in already, you convert all the alphabets to number. So you check periodic table. What's the number for carbon? 12. Then you write down as 12N plus hydrogen. So hydrogen is 4N because hydrogen is 1. 1 times 4N is 4N. Then oxygen, correct, because oxygen is 16. 16 times 2 is 32N. So maybe if I say that, okay, my chemical formula, the total mass is maybe 96. So then now what you need to do is, you see, now that you converted everything to numbers, you can solve for N log. Yeah, so then let's press the calculator. 12 plus 4 plus 32 is 48. So this is 48N is 96. That's why N will be how much? N will be 2. That means what is your molecular formula? The answer is, you cannot leave it like that. Leave it like that, teacher won't give you the final answer mark. So must write out as, it will be C, everything, the N you sub as 2. So become C2, H, 4 times 2, 8. O, 2 times 2, 4. So this is the molecular formula. Okay, so molecular formula means you change all the alphabets into number, add in letter N. Can? Okay, come, let's try. So let me tell you which is a very commonly tested question. By the way, for the MCQ over here, no worries. I've actually typed out the working for you also in the answer key. So if you can't solve, you can see the working, there's explanation inside. Okay, so I would say the most commonly tested question is this kind. Okay, right now, commonly tested question. Hello, write it down. This is also from the RGS, like the WA paper lah. Yep. So they call it as PPA. Hello, write this in. Commonly tested question. So this one is the same concept as what I tested you just now. Remember? Number of ions. So for number of ions, this kind of question, what do you do? Step 1, remember? You go and find the number of moles of ions first. After you found out the number of moles of ions, which is, you always take the in front number. Remember just now, I went through with you the 0.5 mole of H2SO4 one. So you always fill in this number first. Okay, so this is the first number you should write in. So you need to do for A, B, C. You need to write out all the working. Okay, so after you put in the first digit, you go and times how many ions is it all. So in this case, let's write out the chemical formula of the ions. What kind of ions will you form? What ions will you form? Al3 plus, and you have 2 of them, right? Yep. Then you have SO42 minus, SO42 minus, SO42 minus. So total, how many ions do you see? 5, right? Can you see 5 ions? That's why you times 5. Remember, just now we keep practicing this, right? Yep. So then in this case, yep. So you just times 5. So this is the number of moles. But read the question. Is the question asking for moles or not? No, right? They're asking for number of ions. So number of ions means you need the Avogadro's constant. Okay, so that's why Avogadro's constant is for number of ions. Remember, Avogadro constant, that formula is number of ions, number of molecules, number of atoms. So from there, you take the number from above. So that means the step 1 reading, you go and times Avogadro's constant. Then that will be the number lah. But if you realize for MCQ, you can shortcut. You realize that if every single question you keep on times 6.02 times 10 power 3, then may as well just don't times, right? Not all of them you go and times. That means you just based on step 1, you can actually deduce the answer. So that means if you good in this topic, you can sort of visualize a shortcut that I just do step 1, I can deduce the answer. Because step 2 is always the same thing. If you keep multiplying by the same number, you may as well don't multiply. So you just do step 1. But if you don't know what I'm talking about, you just do the full thing. Then you will be able to derive the answer still. Okay, so if you don't know what I'm talking about, you just do everything, just finish up the 2 steps. Okay, so this one you go and count one by one for all of them. If not enough space, can you write on the piece of paper or something. Then you deduce what's the answer. Yep, then you can check with the answer key provided. Okay, so then moving on to the last question for today, it would be question number 8 over here. Just to let you know, question number 8, it would be similar to question number 9. So later, when you do question number 9, can you use the same way of solving? Okay, so you use the same method to solve. Hello, have you all written this in? Okay, so I teach you question 8. You apply to question 9 on your own at home. Okay, so for question number 8, it is the water of crystallization question. This is the second kind of question that I confirm your WA will come out. So because without stoichiometry, is really only mainly this kind of question, which is the number of ions and this kind, the water of crystallization. Okay, so this one, can you label? This is called water of crystallization. So for this kind of question, usually if they ask you solve for the number n, you always present your answer in a table. Okay, this is a method to solve. So once you see water of crystallization question, always draw table. Okay, so just remember for your WA, once you see water of crystallization question, draw in the table. You draw the empirical formula table. Because after all, you want to find n, isn't it like the what's empirical molecular formula kind of question? So that's why you draw in the empirical formula table. Okay, so first row, this time round, is it mass or percentage? It's mass, because they give you mass. Then second line, just copy the table in front. By the way, this time round, I changed from AR to MR because A for atom. Atom is singular. MR is molecule. Remember, I told you molecule is plural. Yeah, so this time round, we are looking at barium barium. They're asking for the N value. Okay, so we can actually use the barium oxide and water because this barium hydroxide will separate out to BaO and H2O. Then why do I use this? Is because I need to use a number here. If it's 4.59 gram of residue means at the end of the reaction. So actually the residue is BaO. So can you follow me and like highlight it? Because residue is BaO, that's why I need to write as BaO. So I need to match. So BaO is 4.59. How much is water? This 8.37 over here is for hydrated barium hydroxide, which is this. But I cannot write this 8.37 here because got the unknown letter N. Then later how I calculate the MR, right? Because you got X, got N, so many unknown. You cannot calculate the MR. That's why I will do for water. So usually for water or crystallization question, usually one column is H2O lah. So you just take note. Okay, later for question 9 also, the right side column is always H2O. So then now, do you know what's the mass of water? So you see, green is 8.37, pink is 4.49. So what's H2O? Correct, because you minus it. Yep, so this part here is because you take the two number, you minus 8.37 minus 4.59. Yep, then you get 3.78. Yes.
Reaction, then you see like the two products, right? So do you know which one's the residue?
Because water cannot be residue. Water is liquid. Liquid, it will be filtrate. Residue, remember the separation techniques. Filtration, we say that residue is solid. Yep, so water is not solid. That's why it will be the other one that's the solid. Something like that. Like yeah, look at the states. Then the rest, I think you all can fill it in, right? So I leave it to you. So once you solve, then you know the ratio, then you will know how much water already. Yep, then done. That's all. Yep, so question 8, similar to question number 9. Then question number 10, it would be the empirical and molecular formula. This one just refer to the table. And remember, I told you molecular formula, just add in the letter N, then change all the alphabets like the ascorbic acid, like got carbon, hydrogen, oxygen, change all of them to number. Carbon become 12, hydrogen become 1, oxygen become 16. Like that. And done. Yep, that's all. Okay, so yeah, let me share with you all the answer key. Okay, so before I give you all the answer key, do you all mind helping me to fill in a feedback form, please? Yeah, so can you all scan the feedback form? After you all fill in the feedback form, I will provide you the answer key. So yeah, can you all fill in the feedback form now? Thank you. So that we can make the lesson even better for the subsequent lessons that you'll be attending. Yep, so people, can you all scan the QR code now, everyone, for both online and physical students? After you are done with the feedback form, I'll give you the answer key. You done submitting the form? Oh, okay. Yeah, so appreciate if you can give us the feedback, yeah, so that we can make the lessons even better. Yeah, so for some of you who heard of this event through your friends, just to let you know, if you want to be updated on like such free lessons, or maybe like sometimes we will Overmark will also distribute like free materials, you just need to follow Overmark on our IG, or you can follow us in our Telegram channel. So for Telegram, just type in the search bar, you just type Overmark. Yeah, so you can follow any channels that is like you think is appropriate for you. And that's where we will always make announcement on such freebies. Yeah, so sometimes it's like free things, yeah, free notes. Yeah, then sometimes it's like that free lessons. Yeah, so for Overmark, because we teach all the way until JC. Yeah, so actually it's good that you follow, because even until you reach like JC, yeah, there will be like free lessons and all. So for Jaylin, you're saying that you don't understand the first row, second row thing. You mean in the notes, is it? Like here? Is it, are you referring to this page? Right. Okay, so what happened is that number of moles, you know, based on the formula in front, what's number of moles? Number of moles is, let me shift a bit, number of moles is mass divided by ml. That's why you just say mass divided by ml. That's why I wrote here is first row divided by second row, because it's mass over ml. It's just following the formula. Can understand, right? Ah, yes.
Question, right?
Uh-huh.
Is it possible to use those formulas itself, or is it just a shortcut?
I go through with you after class 10 so that I can dismiss everyone. If not, end very late. So you're done filling in the feedback form? Okay, so this is the answer key. You can scan and download it. Yep, so this is the answer key for the worksheet for today. Yeah, so once you receive the answer key, make sure you save it somewhere, yeah, so that you can have access in future after you completed the worksheet. Yeah, then you all can pay and go off already then. So hope you all have benefited from the lesson for today, and hope you're clearer and roughly know what kind of questions will come out for exams. Yeah, so that's all for today. So I'm Miss Felicia. So yep, signing off there. Bye-bye.
Oh my god, my computer died.
Oh, you can't scan.
Wait, can you scan?
Okay, let me end the recording first.
But I'm still gonna download it.